So all the algebraic part of the cross product is over. How it's calculated, what is the unit vector which is perpendicular to it, what's actually happening in that, and then the various properties which will help you simplify a lot of problems as far as evaluation of cross products is concerned. All of the algebra or the equations part or the calculations part is over. We will now move on to the geometrical interpretation of cross product. Like, what does cross product actually give, right? It's a different thing that what it gives, the result is actually useful in a lot of physics as well, and that's basically the next thing that we will discuss, cross product in physics. But for now we will see what is actually happening when we take the cross product of two vectors. So I'll have this parallelogram, let it be called OABC. Let A bar be one of its sides and let B bar be one of it be the other side, right? So you have two sides, A bar and B bar. AC is one of its diagonals and OB is the other diagonal. Let the angle between these two vectors be theta. In fact, let me use a different color for this. So the angle between these two vectors is theta. Now, what will A cross B give me? Let's actually look at that. So A cross B is nothing but A, B sine theta n cap, right? Where is this n cap? This n cap is, you have to put a screw here. And then this parallelogram itself is the plane containing A and B, right? Because your A is this, your B is this, and OABC is itself the plane which contains A and B. So your vector, if you want A cross B, you're supposed to move from A to B through the smaller angle. Say moving from A to B like this, right? That means you're coming out. So the A cross B vector that I'm looking for will point out like this. And it is obviously perpendicular to this plane. This is your A cross B vector. This is the direction basically. What is its magnitude? Its magnitude is AB sine theta. I can also write this as A into B sine theta. Right. What is B sine theta? So if I actually drop a perpendicular like this, then this side, this length is basically your B sine theta, right? Because opposite to 90, the side length of this is B, this is your theta, and let this be some A dash, So sine theta is equals to C A dash divided by OC, which is B, so C A dash is B sine theta. So it is B sine theta. Obviously that side length, your A dash C, this is your B sine theta. Now I am multiplying this OA with B sine theta. So in a parallelogram, what I am doing is, this is the altitude, this is the base. So we already know that area of a parallelogram, this is from your 10th class, area of a parallelogram is altitude times base. And what are we doing here? We are doing the same thing. This A is your base and this B sine theta is your altitude. So what is A cross B actually giving me? A cross B is giving me area of the parallelogram. And it's not just giving me the magnitude, it is giving me the vector area, right? Remember, area is a vector. Area is a vector. And what is the direction of this vector? It's perpendicular to the surface. So OABC is your surface, and this vector that you see is perpendicular to that surface. So the area vector is actually pointing in this direction, and the magnitude of this vector is basically this, AB sine theta, which is the area of your parallelogram. So this is area of parallelogram times n cap. What if I need the area of this triangle OCA? As you can see, twice of OCA is area of parallelogram, which is mod of A cross B. Which is mod of A cross B. Why is area? If I need the magnitude of area, then I will do mod A cross B. If I need the entire vector, then I will do A cross B. Because A cross B is ultimately mod A cross B times n cap, where n cap is in this direction. This mod A cross B itself is your area of parallelogram. Twice of area of OCA is this. So OCA will be half of A cross B. So ultimately, what is the entire story? If I have two vectors, if I have a vector A bar and I have a vector B bar, if I take their cross product, ultimately I get the area of this parallelogram. Let A and B be the edges of the parallelogram, then cross product of A and B will give the area of this parallelogram. Its magnitude is given by the magnitude of A and B, and its direction is also given. So A cross B will give the entire vector with both magnitude and direction, right? If I have a triangle, for example, whose I know two sides, maybe A and B. So A bar and B bar are two sides of this triangle, just like this OCA, triangle, where A bar and B bar are two sides. If I need the area of the triangle, then area of triangle is given by half mod A cross B. Mod A cross B will give the area of the entire parallelogram, but I need only one half, right? So I'll do half of mod A cross B. Now remember, this also is this. If I just multiply with half and I don't take the magnitude and I actually take the entire vector, then I will get the vector A cross B, half of A cross B, right? But if I just need the magnitude, I'll take the mod of that, right? So if you have two vectors, you can always find the area of the parallelogram formed by those two as the edges if you take the cross product, right? Sometimes you might also have cases like this, where you have a triangle. This is your ABC. Position vector of A bar is A, position vector of B bar is B, position vector of C bar is C. Now remember, what are position vectors? The vector which starts from origin and goes to A, that is your A bar. This vector is your A bar. This is nothing. I don't know what this is. But to get the area of the area of this triangle, so triangle ABC area, if you need, you will do half of mod of this vector and this vector. You need the sides of the triangle. So you will do AB cross BC. So you will do AB cross AC, take the mod of that and take half of that. That will give you the area of the triangle. But AB bar is basically, let me make some space actually to continue with this. Yeah, so I'm directly continuing from here. This is your triangle with position vectors A, B and C. So you have a triangle with position vectors of points A bar, B bar and C bar. I'm trying to get its area. So area is half mod AB bar cross BC bar. AB bar is B bar minus A bar, right? I hope you remember this. The vector which starts from here and goes to here, that is your AB bar, right? Sorry, your AB bar is reverse basically. AB bar is this, which starts from A and goes to B, right? So it is B bar minus A bar will give you AB bar. Hitting the cross product of this with BC bar, which is C bar minus B bar. Now if you open up this cross product, so this way, open it up one by one. So this is B cross C minus A cross C minus B cross B minus A cross C. Minus or plus A cross B. This term will become 0 because it's B cross B. So area is half of mod of B cross C plus C cross A plus A cross B. So this is also a useful formula. Ultimately what this formula is telling is, if you have A, B and C as position vectors, you can still find the area, and that area will be given by A cross B plus B cross C plus C cross A, and this will be the area of the triangle, half. So you have to make sure that you don't forget this half, right? But remember, this A, B, C are not the sides. The sides are AB bar and BC bar. A, B, C are the position vectors of these points. So from origin, if you join to A bar, A and point A, that will be your A bar. If from origin you join to B, that vector will be your B bar. If from origin you go to C, that vector will be your C bar. These sides are not ABC, right? Remember that. So with this we complete this part of the geometric interpretation of vectors. Let's move on to how cross product is actually used in physics. So this was all the geometrical interpretation of what's happening here, how it looks like. So now if you see two vectors, you should know what their cross product is going to give you, what that magnitude means, what that direction means, right? So let's move on to cross product in physics next.